Test 3, Organic Chemistry, Alkenes, Properties and Reactions. First problem, you're asked to name the following. So beginning here, we recognize that it's a cyclopentene, and the ene predominates in our numbering system. So there are the 5 carbons of the cyclopentene, and then we tack on the bromo substituent and the methyl substituent. So altogether, 3 bromo, 5 methyl, cyclopentene. And you could add a 1 to signify the position of the ene, either in front of the cyclopentene or within the cyclopentene itself. On the second one, we should recognize 6 carbon chain numbered from right to left to position the ene at its lowest possible number 2, and so it's hex 2 ene, also hexene 2 hexene, and then recall enes have the capability of existing in cis and or trans stereoisomers, and if the like groups go in opposite directions, then that's a trans isomer. So trans hex 2 ene or trans 2 hexene. The next one, we should recognize cyclohexene, and numbering the 6 carbons like so. And again, you don't have to put the number 1 in the cyclohexene name. You can if you want to. And then this 4 carbon unit off position number 4 comes in at 4 sec-butyl, and the sec would be in italics. May as well cover the one right below it. Again, it's a cyclohexene, and there's the 6 carbons in the cyclic ring. Could number it 1, and then this time the 4 carbon unit is off position number 3, and that 4 carbon unit is an isobutyl, and the iso is I. So in other words, the iso's not in italics, it's formal, whereas that sec-butyl would be in italics. Begins with B, isobutyl begins with I. Here we have another ene of 5 carbon chain length, so it's a pent, and now you must signify that the ene begins on number 2, either with pent 2 ene or 2 pentene. And now we're going to collect some groups. We have a 3 bromo and a 2 chloro, and they come in alphabetically as 2 chloro, 3 bromo, pent 2 ene, or 3 chloro, 2 bromo, 2 pentene. And then lastly, this one cannot be cis and trans, but using the EZ system, that group priority 1 over this group priority 2, this group priority 1 over that group priority 2, so the highest priority groups go in opposite directions, and that is the E stereoisomer. Here we have 1, 2, 3, 4, 5, 6, again hexene and 2 hexene, and now we have the opposite stereoisomer of the molecule above it because the similar groups go in the same direction, and that we can call cis 2 hexene. This is vinyl chloride, common name, systematically, ethene, and it's a 1-ene, and it's also 1-chloro. So 1-chloroethene. This is just cyclohexene. Here we have commonly called molecule called allyl bromide. If we wanted to systematically name it, the ene takes precedence over the bromide, so the ene is 1,2 of the 3 total carbons. That becomes propene, 1 propene if you want, and then we have 3 bromo. And this is just simply 4 carbon ene, butene, double bond on the end, 1 butene if you want to. For the rest of number 1, which pair are structural isomers? Structural isomer is something that has the same formula but a different connectivity, and that would be those 2. And the stereoisomers are your cis-trans isomers, so that would be those 2. Which molecules used to make polyvinyl chloride? Of course, it's vinyl chloride, and we would polymerize it. And which molecule forms stable carbocations? Recall tertiary halides, and/or benzylic, and/or allylic halides all form stable carbocations. And in this case, that can form a stable carbocation because that halide on a carbon adjacent to the ene is allylic, and also allyl bromide. And what we mean by carbocation formation can be exemplified by allyl bromide. Bromide leaves, leaving behind a positively charged carbon, that is the carbocation, and recall that it's stabilized through resonance, so it can actually exist in 2 different resonating forms.